Hello everyone and welcome back to another preview of the version 11 PCE for Unity, Point Cloud Engine for Unity, and sorry the beta is not out tonight. It was meant to come out tonight, but I really got sort of hamstrung today. Spent all yesterday reworking the converter and have made a lot of fantastic improvements. This new converter converts things much better. The last converter, just say this scene here, I can't remember how many points it has. It was a free point cloud I found online, and yeah, it did take about an hour I think actually about an hour and a half with the old converter, and now it only takes about 4 minutes. So that's a massive improvement. There was a lot of F-bombs dropped in the creation of this converter, but it did succeed. So yeah, so that's really cool. Also, I've because I redid the converter and also changed the format a lot. It currently, because of I was able to actually get everything down to 3 floats: position, color, and normal. They're all 3 floats per point now, as in like 12 bytes. So yeah, so what I can do with that is that in the runtime player, the renderer, I can just decompress everything on the compute shader, so everything is packed nicely, so it reduces basic point cloud to about 30% of its original size. However, because of that, I've included the level of detail in the conversion, because it was just a nicer structure. I can leave it out. I may do that tomorrow. And actually, I'm planning to get the beta out tomorrow, so there's 2 things I have to actually get done tomorrow. And, well, actually, 1 tonight, 2 tomorrow. So, what's going to happen... Sorry for talking so much and not actually showing you much. So, I'll fly around while I'm talking. How's that? Right now, this is just with points active, and you can see the level of detail being changed runtime. Yeah, so the converter will create up to 11 levels of detail, but you can select not to go below, you can select where you want to start from. So I'm actually, for most things, going to be using number 2, because that really gives you 1 point per 3 millimeters, and with the voxelizing the quads, it sort of fills in the gaps and looks really nice for most, say, a triangle mesh converted, a solid triangle mesh converted to points. So that'll give you a nice solid structure. For laser scan data, you may want the original data, so I'm going to add that tomorrow as an option, where all LODs are actually just referencing the original, but from an auxiliary structure, so that means that positions will not be altered. And then the converter, I'll get into that later. There's a lot of settings, but they're all very easy to understand. But you will be able to use the voxelized, which is what this is. So basically, with every LOD, it keeps everything in check. Right now, as you see, the frame rate's still dropping when we're moving. I'm working on sorting that out. So there's a few things going on there that will actually be removed tomorrow, because the one thing I'm doing tomorrow is visual occlusion culling, and that should actually allow me to do a pre-render pass on a much lower level of detail and extract what is visible from that, and then display only those cells that are active on the screen. So that will basically slice everything down to next to basically nearly screen pixel density. So that'll be really cool. Yeah, so I'll show you actually right now. If we voxelize this is the one thing I have to do tonight before I move on. If I turn it into voxels, you see this points get smaller. That's because of triangle meshes. But I can increase that just visually, so you can see that it fills in. and looks really, really nice. So you can imagine that with a really structured point cloud, you really would have the detail that like you'd be able to capture the real world and display it. And honestly, I've tried it in virtual reality, and even at a level of one point per 3 millimeters, which is the 256 capture, it looks really good. I must say I really enjoy the look of it, and so yeah, I mean if I will keep pursuing getting down to 0, which is the 1024, which is the millimeter accuracy, but I don't think it's really necessary for a lot of things in general, but still it'd be nice to have. So anyway, so the plan is tonight to do the get this correct, because as you see when I move right now, it will go to the LOD. You see, I've got to sort out a way of this is what hamstrung me today, was that it seems that Unity draw procedural call doesn't like using the same material in a for loop. So it is seemingly, I may be wrong, I may have done something wrong, but from what I've assumed and actually proved by running the same shader twice, it seems that if you do run it twice in the same script, it seems to not show the second pass. It seems to, like, if you ran it in a loop, say I ran this in a loop, it would show the first level of detail, the third level of detail, the fifth, and so on. And so it seems to be skipping something. We'll make a test and report a bug if I can prove it, properly in a way that you need to be able to understand. But sorry. So what I've got to do is keep the buffer as it is now, like this, where basically it's one giant buffer being sent to the draw procedural, which means that each point cloud should be no bigger than 2 gigabytes at a time. But that's okay. We can load multiple point clouds. Just they have to be broken up for the conversion process anyway, like of the 2 gig limit. So it's not really going to affect everything. I mean, you can still have a larger cloud. It just has to be what's visible on the screen is around 2 gigabytes, and so per point cloud, of course. And basically what you've got available in memory, blah blah blah. Tomorrow I'll probably explain that a lot better. This a bit rubbish, but yeah. So this is the problem I've been having. So as you can barely see it because of what I've got to do is not split the final buffer. I've got to split the pre-buffer, the buffer that fills the final buffer, because right now we got basically the point cloud buffer, which is the actual points, which is one giant long buffer, and then we got the reference data, and that references the point cloud data, and that's one giant buffer, and the final buffer is one giant buffer too. So what's happening here is, what the problem is we've got to do is, for each level of detail, I have to set a scale for each point, and that scale has to be governed by the level of detail. So the way I've got to do it is not split the final buffer. I can't split the point cloud. I have to split the meat, the reference data. So basically, so once I've split that, then it should play nicely, because I need to fill it on the compute shader split, just so I can give each LED its own point size, basically. And it would have worked out okay today, but it seemed that the material didn't like being reused, so I don't know what the hell's going on there. But it did cause me about 4 hours of grief, okay, because I thought it was my fault. I was going through all my code after I made the changes, and it just seemed there was nothing I was doing wrong, and it just seemed to be that issue with the material. So that's okay, that's fine, live and learn. But yeah, so after that, anyway, tomorrow's job, after I square this and get this normal, which I can't wait to see it in action, to be honest. Like, even looking at it now, I'm just like, oh gee, I wish I could play with it right now. But looking at it, points are fine. yeah, when you're moving, you are getting 30 frames a second. That's due to something I'm doing at the moment, but that'll change. I'll cut that out actually. It is to do with instancing and a few other things that I will be able to cure. Tomorrow, when I add the visual instancing, which means that I'll do a pre-pass of the point clouds at a, not a, well, I won't say, like, it's hard. How to describe voxels, octree data? It's still points, but points displayed as quads. I mean, what's the difference? But it is quad tree data, so if you call it voxels, whatever, I'm not really sure, but yeah. So basically, what I'm going to do is from say a level of 7, but down to 10, depending on what you've created your point cloud range LEDs at, because you can select that. It could be, you could have 3 level of details if you want, but it goes down to basically the highest is 11 from 1024 to 1 at the moment. I mean, technically I could modify the converter and you could add a higher level of detail, but who really needs to go below 1mm? I don't really know. So yeah, so once we've got that in place, that'll basically give us a visual screen space culling, so it'll only display the cells, or the cells visible on the pre-pass. Pre-pass should be pretty fast. It was either that or build a triangular mesh and then use Unity's built-in occlusion culling system, which is really cool. Or I could do a BSP tree, but it still, I think, would require really long conversion time, so I wanted a real-time sort of approach to this. So I was hoping to go with basically something we didn't have to wait to convert and could run time. So if I can do this in a pre-pass before this happens, then we're going to have 1,000 frames a second all the time. So or close, maybe 300. I'm not really sure what we're going to actually get, but it'll definitely, in my book, be VR ready, so I'll be happy with that. If I can get it all done tomorrow, it'll definitely be out tomorrow. I know people are waiting and have sort of been expecting it today, but yeah, I just didn't expect to run into this issue today, so I couldn't get everything I needed to get done today. But yesterday was bliss. Yesterday was fantastic. I couldn't believe how everything just fell together. So I was really happy with that converter. That is such a big saving. I was so worried that it would take hours to convert stuff, but now it's done in a single. And even if now I just quickly show you. Yeah, see, you'll only have to press play once and it just does it all in a single script. So that is a big improvement over the previous versions of PCE, because usually you had to uncheck it and check it and check it and check it until you were at the end. But this basically chucks it into an octree kind of, Inception style. So it's basically an octree within an octree within an octree, and well, 2, and then it creates a third one, the third layer of the dream. So yeah, so as it's doing each cell, so it operates really fast, gets everything done. Kind of has to be done in voxels. I mean, you may lose a little bit of precision if you really want the original point cloud data, but honestly, I don't think maybe if you're depending on how you want to use it, because I don't really know how many people want to use it. Like, for the most part, if you're wanting to display point clouds, are you doing it just to visualize and plan, or are you doing it to say this is actually at this specific point in space, and I need that numerical value, but couldn't you just read that off the laser scanner data? I'm not really sure. So I'm not really sure how people want to use these, but I know I want to use it in games and etc. So that's what I'm planning for. But in building use for other people and value, I'm not. It's sort of a little bit of a confusion, but for now, in its current state, with the voxelization of the point clouds, I will still give access to the original data, which will make it a third of its size. But if we include the voxelized LODs, that will make it, in most cases, at a level of 2, which is 256, will be back to the same same size. However, if you use a LOD of 0, which means millimeter accuracy, that can be up to 3 times the size of the original point cloud, depending on, just density and scale of the thing. So, yeah, and plus, at the moment, without the visual occlusion, I can't even gauge, how that's going to play out runtime. But once the occlusion's in, depending on the scene, I dare say it could be totally fine. But I don't want to say something is when it isn't, without testing. So I'm just saying there's a possibility. But to me, a point at every 3 millimeters is aces. Looks great. Anyway, that's enough talking for today. I just wanted to show you something because I know that people were expecting it today, and at least the open beta. But I didn't expect to get hamstrung like I did, but I did. So that's just how it goes. But I had a great day yesterday, and so happy with the progress, and really happy that I think pretty much after this it'll just be a main like developing user requests, which will be fun. I'm looking forward to the fun part of it. So anyway, enough rambling. Thanks guys for listening, and I hope you're having a great day and had a good weekend. Alright, take care. Bye.